about the final exam that you're going to have on May, for May, the 2-hour exam. So you're ready? I start to brief about the final exam. So 2-hour exam, there will be 2 sessions as usual in my course. First session is of course multiple choice questions. You will have 30 questions. You will have 30 questions, multiple choice, having 4 choices for each question, in which you try to select the best answer for each of the questions. So the 30 questions, each of them will carry 2 marks, adding up to 60% of the marks in the final exam. 即係第一部分嘅 multiple choice， 咁佔60分啦，有30條 multiple choice， 每題2分，每個有4個選擇俾你揀 A、B、C、D， 要係 4 choices A、B、C、D to be for each of the questions. And basically, and also the second part is long essays. It's long essays that you expect to complete. For 3 questions, you will have to choose 2 out of them. Long question 咧就3揀2咁樣啦。So each question will carry 20 marks. So you answer 2 of the 3 questions, you will have 40 marks. So after all, it is 20 marks for each question. So don't just write too shortly. So you can expect, I don't have a model answer about how long you should write, but you should expect to write more than 1 page. I mean, not in alternative lines. Basically, maybe 1.5 page is general standard, according to my experience of marking exam in this course in the previous year. If you write, some students just write 2 lines or 3 lines, it's very likely that the person will get 0 marks because you didn't catch any point, you didn't explain anything, you didn't elaborate. So when you approach the questions, try to think about what are the concepts involved, and try to explain the concept, try to define the concepts, explain what is the meaning of those, and then also maybe to give examples accordingly and to illustrate your point. Sometimes the question didn't ask you for examples, but if you think the example is useful in explaining your points, then why don't you just write about it? So I say, I don't like using model answers. I know some students and some teachers like to use model answers for essay question. Like, if you write this keyword, I give you 1 point. If you write that keyword, I give you 2 points. I mean, it is for high school. So in university, there are many different possibilities that you can get right about a questions. So basically, you try to think about what the question is asking, and don't just answer your questions outside the scope. Try to think about what the question is asking you, and then answer them, tackle each requirement accordingly. 即係我哋老師之間都有好多感覺嘅咯。啲同學咧有陣時唔睇題目嘅，佢淨係講佢自己想講嘅嘢，咁變咗佢完全唔係答緊嗰個題目啦。You may be on the topic. For example, the topic is about asking about IQ, asking about the Binet test. But you just write. You write only what you know about IQ, but you are not answering specifically what it is about. So be careful. Make sure you are tackling the questions reasonably. Make sure you are answering the different parts. You are providing answers to different parts according to what the question is asking you. So I think this is very basic kind of exam techniques, right? So that is it. 2 parts, 60% multiple choice, 40% for long essays. Expect to write more than 1 page for each of the questions. And sometimes I see some students can write for 3 pages, 4 pages, and one of the questions is very fast writing speed. So to distribute your time, you expect to complete the multiple choice questions maybe within the first hour of the exam. Then you leave the remaining hour to complete about the long essays because you will need longer time to write, and then also reserve some time to recheck your exam answers before you submit at the end. I think this is the general instructions. Then about the scope, you care about the scope, you don't like about your tutorial, mathematics and statistics. So don't worry too much. Just like what I said to you in the midterm test. So basically, it is mostly about the lecture materials. And from week 1, reliability, validity test development, and theory of intelligence and BNet test, business intelligence test, personality test, and also up to testing in business and occupational settings, not including replication in psychology and test bias. 即係去到呢度啊，去到 test in business and occupational setting 以上嘅 lecture topics, not including replication psychology. And then you ask, we include some of the things in the tutorial. First thing is you don't do SPSS in the exam hall. We don't have computer for you, so don't worry. Then you need to do perform an SPSS analysis right away in the hall. But mostly I don't ask you to do a correlation or regression and do an ANOVA right away. I mean it's already tackled in your individual lab exercise. But does it mean that tutorial material is totally not included? I cannot guarantee because there are a few, there are very few in 1 or 2 or 3 several key concepts that you have covered in tutorial, which are also corresponding to certain materials in the lecture. Like what is the meaning of criteria validity, predictive validity, and what is the meaning of non-reference test, what is the meaning of norm and standardization sample, what is the importance of the number of items in a scale. Okay? So I expect you to study about those conceptual things. So some people will even ask me, do we need the calculator? And you can bring the calculator. I mean, I've written in the exam regulations. You can bring the calculator, but it may or may not be useful, and you may or may not need it. But even if you need it, it will be minimal. It's like if you don't need it in the midterm, then you don't need it in the final exam. Okay, but you can bring it for having a more peaceful mind with yourself. As a lucky item with you for the calculator. Okay, so this is what I need to say or what I can say about exam. You know that after all, in any situation, I cannot tell you any of the research or the exam questions. 即係我係冇辦法去同你去即係透露任何嘅問題咁啦。But well, that is it. I can only tell you about the format of the exam and the scope of the exam. That is it. Okay, but then if you ask me, I'm thinking about how to do a revision on this course, so what are some of the topics that you think it is very important, very core in this course? Then I will include the following topics that I think to be some core important topics in this course. Then I recommend you to understand them well. Okay, so first thing is on reliability chapter, we start this course by learning about the classical test theory model and classical test theory. That is, we learn about what is measurement. We learn about any measurement, there is a measurement error. We learn about the rubber yardstick example, which can stretch. So the observed score equals to the true score plus the error term, which the error can be large or small, can be positive or negative. That's why reliability is related to how small is this error part. If you can eliminate the error part, that means your observed score will be representing the true score. But this can never be eliminated. So we want to minimize the error part. Classic test theory. And also, we also learn about the related item response theory. There's a new generation kind of approach in testing. Rather than giving you a set of questions already decided before the exam, we try to give you the questions depending on your real-time performance. You answer several questions at certain difficulty incorrectly, then the computer will distribute some easier question for you. If you answer them correctly, then it will raise the difficulty level for you. So every test taker will have different questions that they see, because after all, the test questions are delivered based on their real-time performance, right? Item response theory. Then we also go into validity chapter. So what I want you to really understand from this course is get an idea and be able to explain what is the general concept of reliability and validity. this is core, all the time this is core. Reliability means stability of the test results. Every time under same condition, measure same people, measure same characteristics, it should give you similar results, it should give you same results, right? Validity is whether measurement is measuring what it's supposed to measure. This is the general concepts about reliability and validity. And besides this general concept, I also want you to be able to recognize and be also to have an idea about the specific kinds of reliability and validity that we have come across. And very simple, right? Test, retest reliability. Measure people 2 times and using same measurement, you expect similar results. And then iterator reliability, split half reliability and internal consistency that you learn in your individual lab exercise, Chromebook solver, dividing the test into 2 parts and then try to calculate correlation between 2 parts and divide it into all possible ways and then the average the correlations, Chromebook solver. And then for validity, you also learn about face validity. It's not true validity, is the face value, is what the test appear to be measuring is face validity. Then content validity, construct validity, criterion validity, under which we also have the concurrent predictive validity. For the construct validity, we have the convergent and divergent validity. So I don't need you to memorize all those numbers associated with particular tests. What is the validity for the weights, and what is the validity for the MMPI? You don't need to memorize the numbers, but I hope you understand and be able to explain the concepts and what are their meaning, be able to differentiate them. Okay? Then also, after talking about these, we also talk about the relationship between reliability and validity, right? So if you have something that's reliable, that means every time you give the same results. But the same results doesn't mean that it is valid. Just like you can give an example, like using a bathroom scale reading to measure your IQ. 用室磅幾多公斤你去測佢哋去稱下你個 IQ 幾多嘅。You know that a bathroom scale reading is reliable, all the time is accurate, but it is just not representing intelligence. It is not a suitable choice to measure intelligence. So it has perfect reliability, but poor validity. It just does not represent validity. On the other hand, is it possible that something is valid while it's unreliable? It is not possible. Because if something is unreliable, every time you get some random number, you just don't know what is the meaning of those random numbers. So there's no validity. After all, validity means meaning, and validity means what the measurement means, right? Is it meaning what it's supposed to mean? So reliability is a precondition of validity. You have reliability, you may or may not have validity. But if you don't have reliability, then you must not have validity, right? This is something that we have learned about. And then, like some concepts about what are factors affecting reliability. One of them is from the domain sampling model. The test items are actually trying to represent the domain of knowledge, represent the domain that it aims to measure. And just like the final exam, it aims to measure the domain of all psychology knowledge that you've learned in this course. But in the test, you only have limited number of items. Just like in the research, you only have limited number of sample size to represent the population. So then it comes to a question saying, would the test items represent the domain well? One factor is depending on how large is your sample size, or in other words, depending on the number of test items that you have. If you have more items, then it tends to represent the domain better. Just like in research, if you have more participants, it tends to represent the population better. So the number of items is quite related to reliability in general. And then on the next chapter in test development, we learn about things like item formats, like dichotomous formats, polytomous formats, like multiple choice questions, like some other categorical formats, like the visual analog scale, those things. I hope you have a concept about them. And item difficulty, let's talk about our particular questions, particular item. How many percentage people get it correct, people get it incorrect. So item difficulty is if the number is higher, then means the item is easier. I hope you don't get confused. And then item discriminability. We try to locate and try to identify whether a particular item can be able to help us to differentiate people with high performance and low performance. Okay, remember those item characteristic curve. Okay, we can determine if a curve is having a slope across all different level of performance. That means the item is sensitive in differentiating people with all different kinds of performance. If the curve is flat, that means it fails and it is insensitive to differentiate people, and then for performance item discriminability. Then we go on to study IQ and intelligence. We have learned about some concepts of intelligence, like what is fluid intelligence, crystallized intelligence. Fluid intelligence is some potential that you have in learning new things, in being flexible, in problem solving. Well, crystallized intelligence more like previous knowledge that you have learned. And then we studied the background about how Binet tried to develop the first IQ test. Then he followed, because of his difficulty, he tried to follow two principles. What are these two principles? I hope you remember and know that. Principle of age differentiation and also principle of general mental ability. Age differentiation, say that we expect that people at different age and child at different age will be able to perform different functions, will be able to perform different things. A child at 9 years old will be able to do multiplication, but a child of 3 years old, you don't expect him to be able to do multiplication. And the general mental ability is there is something, underlying factor analysis. There is some underlying general factor that affect the performance of specific factor, affecting the performance of specific test outcomes. So we can have no method to measure the specific factors or index, but overall we believe we can have one general number, that is an IQ number that represents a G. Understand the concept of G. Then he also contributed to the development of the early IQ concept. Remember what is the early IQ calculation? IQ was equal to mental age divided by chronological age in the early versions of IQ test. Then later on, in some other versions, later on, people say, wow, with this concept, we have different SD across different age. So we try to standardize it using the deviation IQ concept. So I hope you understand deviation IQ concept. It's standardized so that every age level we have the same mean and we have the same SD. You can compare people's performance across different age in a developmental study, for example. Then we also talk about baseless tests. And then on the personality test chapter, we have learned about 4 particular strategies of personality test construction for structured personality tests. I hope you know about them and be able to explain them. What are these? One of the big categories is the empirical type, empirical research, empirical strategy, including factor analytic strategy and also the criterion group strategy. Basically, it says we don't depend on a particular assumption or theory. We just look at the data, use the data to develop the test item, use the data to select items which are most effective in differentiating people. I don't care about face value of the test item. I just care about its differentiating function. I just care about whether it is effectively helping us to categorize people. And then on the other hand, it was a deductive strategy, including the logical content approach and also theoretical approach. Logical content approach is based on face validity. Does not based on theory, it does not based on data. It's based on what you think about the test should include. Let's say I'm planning to develop an eating disorder test. I would think that logically, eating disorder should include problems in appetites. Do you have appetite in eating your lunch and dinner? If you say no, that means you have 1 point higher. You gain 1 point in this scale. But whether this question actually or statistically categorize people with or without eating disorder, we may not know that. We just depend on your feeling. We depend on your intuition that logically should be reflecting eating disorder. And theoretical approaches we look at the literature and depend on a particular theoretic framework, and then follow the structure to develop the test. Let's say we believe in Big 5 personality dimensions. Then we develop a new test with the framework having 5 different components. These 4 kinds of strategy, I hope you are able to understand what are they and be able to know their differences. Then about the particular personality test, we study one of the very large tests is MMPI. MMPI is famous about its having the content scale, validity scale, the LKF scale. Do you remember validity scales? What are they? You read through the development of MMPI. Know about the functions of these different kinds of scales and content, clinical ability scales. And we also come with examples of combined strategy, especially the Big 5, the NEOPI, NEOPI personality inventory. And then at the end of the personality test chapter, we also study several, I think 5 or 6 different short positive personality scales, measuring self-esteem, and Rosenberg self-esteem scale, measuring self-efficacy, measuring hope, measuring life orientation, these kind of things. I hope you have a rough idea. Remember some of these examples of short personality tests, positive characteristics. And then on the business, business occupational chapter, we learn about the SVBI and most importantly, Holland's scale. I hope you know, memorize the 6 different dimensions of Holland and what do they represent. The realistic part, realistic dimension, investigative dimension, artistic dimension, social dimension, enterprise dimension, conventional dimension. What are these? And what may be some typical jobs that are related to these 6 dimensions and the reaction affect people's personality. Okay, so if you study about these concepts, I think these are the core knowledge in this course. If you can study them well, then I guess probably you are not likely to have a problem in passing the exam. Okay, so again, I'm not saying these are the exam questions, right? I'm just saying these are some good topics that you can start with in your revision, some core topics. Okay, so in the remaining, we need to carry out our main job to complete the course anyway. So why? We have been talking about there as a lot of classic psychological studies that we study in the textbook. It seems that they are so reliable. After all, we cannot replicate their results. What are some of the reasons behind why those studies cannot be replicated original results? Why psychology is so weak in replicating results? What are some of the reasons? So this set of notes, I actually created this out of this particular research paper. The research paper in 2015 talking about replicating psychological science. So the author trying to list out 3 major core sources leading to irreversibility of the results. The first one is related to statistical problems, roughly related to low statistical power of the research study or the measurement, or publication bias, and people try to show their results so that they can be accepted by journal papers to publish, and also a lot of people try to publish results that have p-values smaller than 0.05, it's p-value 0.046. 0.049, it's smaller than 0.05, but actually it's very selective. It's not really reliable. And second is researchers in psychology, a lot of them have a bias. They have personal bias to make the study successful, so that they do something called p-hacking. That is intentionally try to adjust the sample size and try to adjust the experimental condition to get the p-value just more than 0.05。即係用某啲手段出一啲蠱惑，咁導致個 p-value 啱細過0.5咁可以出蚊啦咁樣。Number 3 is problems interpreting correlation. Sometimes people just look at the R, say it's large or slow or small, and make the conclusion without actually reading the pattern. Number 4 is misinterpretation of non-significant results. A lot of students like you guys will say that the p-value is non-significant, it's more greater than 0.05. That means improve the H0. The thing is, you can never prove H0. Just like can you ever prove there's no alien in the universe? 你可唔可以證明呢個宇宙係冇外星人呢？ 咁你冇辦法證明佢嘛？你只可以話我哋仲未揾到證據話有外星人，咁唔等於冇外星人。Just like in the court, you cannot find strong enough evidence to prove the suspect to be guilty. It doesn't mean that the suspect is really not guilty. 即係可能嗰個被告咧其實係有犯罪嘅，但你告佢唔入，唔等於佢冇犯罪㗎嘛。你告佢唔入，唔等於你證明咗冇犯罪，你只係未能證明佢有做嘅。So non-significant results just mean that you fail to find evidence to demonstrate what you are. So this is what I briefly described previously. There are 4 possibilities in this kind of signal detection situation. Just like doing a psychological research, just like doing a detection about some effect exists or not. 4 probability, 4 chance, 4 combination. First combination is there is an effect. Why don't you say there is an effect? There's this one here, power. There, in fact, in reality, there is an effect, and then you say yes, there is an effect. So this is a correct decision. It relates to statistical power. Whenever you read psychological research paper, some people say that the limitation is that there's a limited power in this study. The power we're talking about is the statistical power. Basically, it is the conditional probability that H1 is true while you conclude H1. Second combination is the type 2 error. That is the probability that there is an effect while you fail to conclude its effect because you see p-value is greater than 0.05。即係咧，可能一個 treatment 係真係有用嘅，但係你未能證明佢有用，咁唔等於嗰個你證明咗個 treatment 冇用㗎嘛。Maybe it's because of your methodological limitation, technological limitation, or small sample size, or big variance in the data, big variance in your research participants. It's not the fault of the phenomenon. It's the fault of the people carrying out the study. So, and it's this type. In reality, there is an effect, while you say there is no effect, because p-value is greater than 0.05. And then correct rejection is the case that there is no effect while you say there is no effect. It's this one. Probability that there is no effect, so that the p-value is greater than 0.05. You didn't reject the H0. So type 1 error is the one that we want to avoid. It's the probability that there is no effect while you wrongly say there is an effect. 即係明明人哋冇嘢嘅、冇用嘅，咁你話佢有用。Or like imagine if you go to see a doctor, the doctor say that you have cancer, but actually you don't have cancer. Your doctor say you have cancer and try to do a surgery, open up your body on you, and then open up your body and find, wow, no cancer. I'm sorry to open up your body. Can you accept that? Of course no. 或者你個醫生同你講你有癌症喎，幫你劏開你個肚咧，就幫你拎佢出嚟啦。劏開咗個肚之後咧，發現你冇事喎，咁sorry 啊咁樣唔該晒，咁你可唔可以接受到咧？好難接受㗎。This is type 1 error. This is something that we want to avoid in psychology as well. We want to avoid a false claim of a non-existing effect. Mathematically, it is reflected by p-value. Okay, so having understand this, then we can go into studying the 4 different core reasons for those non-replicability of the results. Number 1 is low statistical power. Power is probability that there is an effect while you say there is an effect because the p-value is small. So under what situation you can have a significant p-value? Usually, you need to make a very low variation. Make sure your data have very small SD, very small standard deviation. Make sure your data you have a large effect size. While both of these ultimately is related to the sample size. So if your sample size is large, then you will have smaller SD in the data, larger effect size, making you have a larger power so that you have larger probability, larger chance to get a significant p-value. This is one technique that people or psychologists would use to obtain significant results in getting a larger sample size. Probability of finding an effect exists or difference while effect exists. It is affected by small sample size and effect size. A lot of psychological research why they couldn't replicate the study because they are using a small sample size, or because they are actually studying on the effect with very small effect size. Okay? So that they obtain the significant results by chance, by luck. Then the next time when some other psychologists try to replicate study, they fail to replicate it. Okay? Because the first time, the first people who report this research results, they just obtain it by chance, they just obtain it by luck. Okay? So this kind of low statistical power could not guarantee you to be able to replicate the results next time. So second is publication bias, research bias. So if you understand people who do research, or people like me, okay, people like any teacher that you have in the university, professors, okay, how do they secure their job? How do they get promotion? How do they develop their career? Through publishing papers. And people know about the phrase publish or perish. It means if you don't publish paper, then you will disappear from the university and people will fire you. So we are receiving a lot of stress and pressure in making constant preparation every year. So how to publish your paper? And in the journal article, in psychology, and a lot of times psychological journals and journal office tend to only accept paper, then report a significant results. If you do a research and find non-significant results, and you send to journal papers, nobody is basically going to accept you. I know there are only one or two journals in psychology that they explicitly say that they may consider non-significant results, given that you have a very, very good research design. But for majority in psychology journals, they just reject directly. So people need to do everything to make sure that they get significant p-value. Then what will they do? They do things like optimal stopping. Just like I collect data, I don't have a target sample size. I just keep collecting. If I get 30 data, does it get significant results? Maybe the p-value is 0.06. It's not significant enough. Then I increase sample size. I get 50. Is it significant results? Maybe then 0.055. It's still not significant. If I get up to 80, what is p-value? P-value become 0.4 something, 0.45, 0.045. It gets significant result. Then I stop. It seems that we don't have a particular plan beforehand. We just continue to collect data until the time you get a significant result, and then you stop. So people are using this to hack the p-value. People are using this trick to publish a paper. So some people say that statistically speaking, theoretically, you will inflate the probability of committing type 1 error if you go on to do this all the time. 即係咁如果你每個 research 都咁樣做嘅話咧，咁就其實就大大咁樣增強咗呢個 p-value 嗰個錯誤嘅機會啦。So you are actually distorting the meaning of the p-value. The p-value is not as small as you observe if you selectively collect data like this. Or people just report research having p-value just slightly smaller than 0.05. It is the minimum acceptable significant level of 0.05. You get a result 0.045 and publishing. So people say a lot of times psychologists publish paper having this level of p-value. And if you and I, everyone are doing this, it will inflate the type 1 error a lot. So there are also some techniques that psychologists will use to hack the p-value, so to make the p-value smaller. There are some techniques to achieve a desirable p-value, usually smaller than 0.05. People sometimes will do the following. Drop certain subjects. If they say that you see that out of the 100 subjects, there are 20 subjects that are not showing the expected pattern of results. We drop them. We don't include the analysis. So this is very selective. This is actually cheating, right? 見到某一啲嘅 subject 嗰啲 data 唔靚嘅咁直情就整走佢咁當冇事發生咁當冇收落去咁淨係擺啲靚嘅，淨係擺啲啱自己心水嘅 data。Or observation measures or experimental conditions that yield inconsistency data. Let's say I have conducted an experiment having experiment 1, 2, 3, 4, 5 conditions. But condition 4 and condition 5 are not showing the expected direction of effect. So that I just don't report them as it never exists, as it never conduct condition 4 and 5. Actually 4 and 5 conduct, only that they show non-significant results. Or apply fully motivated post-hoc data transformation. If you remember, when we learned in research method last chapter, it's saying that a lot of statistical tests require you to have a normal distribution of data. But a lot of time in practice, you don't see a normal distribution of data. You may see a data bias, you may see a data is biased in different ways. Then you learn about one way is you can mathematically transform it, the data, so that the transformed data is not the original x. You can transform it by making it 1 over x, or making it to take a log of the x, or take the square of x. After you do this transformation, the non-normal data become normal. 即係啲唔係 normal distribution 可以咁用數學方式一除 x 或者 log x 或者唔知點樣 square x 咁 square 咗佢 log 咗佢之後變咗 normal distribution. And make it normal. Then you do the statistics and do the t-test and over correlation regression on this transformed data. But then after all, it is log x, for example. It is a log x. What is meant by the log x of condition A of group A? The log x of group A is significantly different from the log x of group B. You know the meaning if you are saying that the score x of group A is different from the score x of group B. For example, the CESD score of group A is significantly higher than the CESD score for group B. You know this group A is having more depression, right? But then if I tell you, the group A has a higher log score of CESD than the group B log score of CESD. 咩叫做 group A 嘅 log CESD 係大過 group B 嘅 log CESD So the interpretation is problematic. A lot of people are doing this kind of things to make the data normal and to interpret data wrongly, or use questionable covariance in the analysis, like ANOVA and COVA analysis of covariance. You can input the IB, you can input the DB, you can also input some covariance to adjust the level of IB-DB relationship. But then when you insert them into SPSS as covariance, some people just don't concern about it. To be a valuable or to be an appropriate covariance, it should have some relationship with the IB and DB. You should not include something totally unrelated as a covariance. Or suppressive measure experiments that didn't work, that's what I described. Or use optimal stopping strategy that we described in the previous page. You collect data. Only when you get a spot and 0.05, you stop collecting data. Or intentionally increase sample size to push the non-significant values, p-values into significant. This is something that a lot of people are doing, a lot of psychologists are doing. They are finding a very small effect size. When they have a sample size of 30, it's not significant. Then they increase sample size of 50, it's not significant. Increase sample size of 100, it becomes significant. Then they report. So after all, why does it happen? It's because you know that, for example, you do a two-sample t-test. The two-sample t-test, the p-value depends on the t-score. The t-score, actually, what does it depend? The t-score is calculated with the mean, with the score. For example, we have group A and group B. Group A and group B's mean is significantly different or not. Minus the hypothesized value, mean A minus mean B. Under the hypothesis, it should be 0. And then divide by what? Divide by standard deviation over square root n, and there is a standard error, right? So how to make this number large? If this number large, then t large. If the t is large, then the p value is small. You can get significant result. 即係如果你可以將呢卡嘢變成整大佢咧，咁啊 t 就會大。個 t 大咧 p value 細 ，p value 細咧就 significant 啦，咁樣。So after you can look into this, it's related to the n here. If you have a large n, then you have a small number of s over group n, right? 你覺得嘅 n 大話，你呢嚿嘢咪細咯。If this thing is small, then this whole number is large. So in conclusion, if you increase your n, then your t number will also increase accordingly, leading to you to a smaller p value. This is some techniques that people mathematically make the non-significant p value become significant by adding up the sample size. So number 3 is wrongly interpret the correlations. So significant statistically significant correlation obtained with small sample size should be interpreted with cautions. Okay? Other than p value, where r value, you should also report a means and confidence interval. And use scatter plot to look at the correlation. If you look at this, if you look at this situation, these conditions, number 1, 2, 3, 4, if you do a linear correlation and you do a Pearson correlation, that they all will have the same R value. 即係我哋將呢4 set 嘅 data 擺入去嘅 SPSS 個 Pearson correlation 咧，佢個 R 一樣嘅 ，P value 一樣嘅。Does it mean that these four patterns of data are actually having the same kind of relationship? Actually, no. Only situation 1 is having a linear relationship. Situation 2, you better describe it as an inverse U in relationship， 一個反 U 嘅一個形狀啦，係咪？我話 inverse quadratic relationship。Situation 3 is actually a very near perfect linear relationship. Only that there exists outlier. This is different from situation 1 where you have a lot of variance in data, right? In situation 2, basically you are perfect. While in situation 4, basically everyone is having the same x while they have different y's. It's not like this kind of situation that you have data everywhere and that you have a positive relationship. So note that all these 4 data sets, all these 4 situations, they have the same means and same means for x and y, and variance for x and y, the correlation R for x and y, and the best fitting regression line. So if you don't read about the scatter plot, you don't see the scatter plot, you will wrongly conclude these 4 situations are having the same results, same xy relationship, xy correlation. Lastly, this one is this graph is a little bit difficult to interpret, so pay attention on here if you want to understand this. So interpretation of non-significant results. I said many times that non-significant results doesn't mean that you have proven there is no effect. Doesn't mean that you have proven H0. You can never prove H0. Just like that, you can never prove there's no God in the world. There's no alien in the world. So assume that we have conducted an experiment with 2 conditions. One is the control group, another is the experimental group, or control condition and experimental condition. So under the control group, the mean is 50, the SD is 20, the number of sample is 24, described by this 2 normal distribution. 即係 control group 裏面嘅分咧，平均分就50，normal distribution SD 20。So assume that these people undergo an experimental conditions. For example, you turn on the lights. You turn on the lights so that their performance increase. So the performance increase from the control condition blue line to the red experimental condition line. So then their performance now, the mean is 60, while the SD and the sample size remain the same. 即係假設你叫人哋喺間黑房嗰度做嘢，同埋咧你叫人哋開咗燈之後俾佢做嘢，同一班人做嘢，咁佢嘅 performance 增加咗10分啊。Assume that this is what is meant by sample effect size. Effect size means the mean of the experimental group minus the control group. Is this distance. Effect size is actually 10. The size of the effect is actually 10. More strictly speaking, you should also divide this number by SD. Because SD is 20, so 10 divided by SD 20, it gives you an effect size of 0.5. 即係呢度咧即係由 control group control condition 去 experimental condition 咧增加咗10分。咁呢個10分咧就除翻 SD 咧就係0.5，我哋會話個effect size 就係0.5啦。We say that the effect size is 0.5 for this experiment. Let's say we do this with a pair t-test and look about the p-value. The first time we conduct this t-test and looked about the p-value was 0.059. So that this is the mean, this is the 95% confidence interval. If this mean, if this green dot is located inside this orange bracket, orange rectangle, it will have a significant result. Now this is non-significant result, so this green dot is outside this original, this orange rectangle. 即係如果呢個係細過0.05嘅話咧，咁佢呢一個60點就自然會搭咗入去呢個橙色格入邊啦。咁呢個0.09啦，咁啊緊揩到條線就搭唔到入去。So let's assume that we repeat this experiment with another 24 people, and then look about the p-value。This time p-value is 0.425。將呢個實驗咧，再揾另外24個人重做一次。咁今次發現咧 p-value 0.4幾喎，咁樣完全唔正確嘅，it's not significant. If you assume that you will repeat this experiment with 24 people, okay, 25 groups of people, 25 times， 重做呢個實驗25次，揾25批人重做25次。Every time you know about p-value, this time 0.9, this time 0.21, this time 0.013, 0.033, 0.21. Then out of this 25 times, you will find that actually 15 times out of this 25 times, you get non-significant results. In other words, it means out of this 25 times, you get 10 times that you get significant results. Okay. So it is, imagine that you are the researcher. You only have the chance to do the experiment once. Okay. 如果你真係做嗰個 research 咧，你淨係會做個 research 一次嘅嘛。You do the research once and you obtain p-value of 0.059. You want to conclude that you do not reject the null hypothesis. But actually, if you have chance to repeat this experiment 25 times, there are 10 times that you actually see the significant effect. So even if one time of non-significant results, it doesn't mean that you have proven H0, then there is no significant effect. 即係如果你淨係做呢個實驗咧，有機會做25次嘅時候咧，其實你發現咧25次咧有時有10次咧，佢係會做到 effect 出嚟，有15次做唔到 effect 出嚟。咁如果你做呢個實驗咧，淨係做一次，咁你見到 P0咁你唔夠喎，咁想 conclude 其實佢冇 effect 嘅咁你就會失去咗去 detect 呢10次佢有 effect 嘅機會啦。So you will wrongly conclude there is no effect. But if you have chance to repeat this experiment many times, you will find that sometimes you can find significant results. So it is not totally no effect. It is a case that you have low power. Okay? So that a lot of time it has effect, but you fail to demonstrate the effect. Sometimes you are lucky enough to demonstrate the effect. How to improve this? One way is you get a larger effect size, but usually very difficult to control. Another way is you get some more participants with some less variance, some more homogeneous participants. 即係整大啲嘅 sample size 啦，同埋揾一啲一致啲嘅人去做個實驗咯，咁你就會容易變得高嘅 power 啦。So this is a problem of interpretation of non-significant results. So non-significant results, how to deal with it? Non-significant results, even with a very large p-value, for example, p-value equal to 0.65, it's very large, it's much larger than 0.05. It does not necessarily support or prove anything. It just fails. It just means you fail to support H1. It means you fail to support your research hypothesis. It doesn't mean that you have proven no effect, proven nothing exists. This is type 2 error, in which it is possible that the effect actually exists while you wrongly conclude it doesn't exist. Just like previous page. There is in fact with this treatment, while a lot of time you will tend to wrongly conclude there is no effect. So what is the appropriate way to, if I really want to prove something has no effect, if I really want to prove group A and group B has no difference, for example, I want to prove that psychology major and also counseling psychology major, they have no difference in IQ, then what we should do? So normal statistical method cannot do this. Normal statistics can never do this. But if you want to conclude this is more confidence, you can with larger sample size and with more homogeneous samples, with smaller 95% confidence intervals, that means with some participants having a smaller standard deviation, having smaller variations. 就揾一啲人翻嚟咧，相似啲嘅，大家唔會太過唔同嘅。Or having a smaller variance in the case of smaller differences and the smaller effects. And then by improving your control of the conditions of the environment, using better measure with better reliability and validity. And the author also mentioned about a very technical statistical method. You know that in statistics, you learn descriptive statistics and inferential statistics, 描述性統計同埋推斷性統計. There's a third branch of statistics that a lot of us may not have learned about. That is Bayesian statistics. 呢個貝氏統計學。 另一個體系嘅Bayesian statistics is another system of statistics. This is very powerful in that it can be used to estimate the extent in which the results support the null hypothesis. It is some statistics method that allow you to prove the null hypothesis. But it is very technical, very mathematical. Even I didn't study about this. And if you like mathematics a lot and you are interested in this, then you can study this paper about Bayesian analysis, Bayesian statistics. I think it's something related to the understanding of conditional probability, something like that. I didn't remember, correct me if I'm wrong. Conditional probability of A and A given B equal to conditional probability of B given A times probability of B, I think. 係咪咁啊？好似係類似咁啦，唔記得咗呢個係 A 定 B 即係咁樣可以咁樣反轉啊 conditional probability. So it is the fundamental principle of Bayesian statistics, and that you can learn about if you are interested. So in conclusion, how to improve replication psychology? First is pre-register your design, and after you design it, you carry it out. Don't change your design, don't change your target sample size, don't change your target number of experimental conditions. Once you have designed on it, once you have fixed on it, then don't change while you are carrying out the study. So increase the statistical power by having a large sample size, maybe approaching 250 if you are doing a standard questionnaire measurement. Or other than p-value, r-value, also report some other things like confidence interval, scatter plot, means, and some other information. And be transparent in data, open peer review process and publication, and share your data with some other researcher so that let them try to analyze your data and see if they can arrive at the same conclusion. So the final conclusion about this is, does the failure to replicate the results in psychology means that original psychology studies are wrong, like mass model tests and facial feedback hypothesis, those classic studies, are they wrong? They may not be wrong, only that they are not replicable all the times. Because after all, you think about this, you are studying psychology. You are saying it is easy comparing with subjects like physics, chemistry, mathematics. It's not that technical. Comparing with computers or IT, it's not that technical. But then psychology is difficult to study is because we are studying human behavior. Humans are difficult to understand. Human itself is a difficult problem to study about. So finding about answers from psychological research shouldn't be easy at all. We are studying something that's very complicated. We are studying humans. So I think in single study can never provide definite solution or conclusion for or against an effect and its explanation. And that's why repeat and research keep on studying. Replication is repeat the process. Embrace this dynamic process of knowledge development in psychology. So I hope it give you a new motivation about studying psychology as a student. You are approaching your final year. So try to read about this paper if you are interested. So let's take a break of 10 minutes and then get back at 4:20. 4:20，我哋就再講埋剩低最後一個 topic。So we will continue on the final topic 10 minutes later. Let's check out